Okay, so this is our second video on functions, and should get it finished in this video. So the next type of function is a cubic function, and we know obviously it will be like x cubed. Okay, so for a cubic function you're always looking for a power of 3. So example here will be 3x cubed plus 7x squared minus 9x plus 4, or g of x, it could simply be minus 2x cubed minus 7. Okay, once the cubed is there, that's showing you that it's a cubic function. For a cubic function, you should expect to see two curves. So if you remember in a quadratic function, it was either going to be U-shaped or N-shaped. For a cubic function, you're looking at two curves. So if it's a positive x cubed, okay, what you're looking at is it starts by going uphill. It has one curve and then another curve. So looking at it going uphill from left to right to show that it's positive. Okay, and if it's a negative x cubed, we're starting downhill from left to right, one curve and then another curve. Okay, now they're just examples. As I said before with the quadratics, it's not necessarily going to have a perfect U and a perfect N shape together. It might be just a slight bend or a slight curve, but that's what you're looking for here. Okay, so if we start our example, graph the function g of x equals x cubed minus 6x squared plus 11x minus 6 in the domain minus 0.5 to 3.5. Okay, so we're going to draw our table again. We have our x values, which is our domain. We have our function is x cubed minus 6x squared plus 11x minus 6. And we have our y values, which is our output values or our answers here. So if we're starting at 0.5, yeah, so they're all positive values. So 0.5, we might go up to, we'll go up in 0.5. So 0.5, we'll go to 1, 1.5, 2, 2.5, 3, and up as far as 3.5. So this is definitely one where I would be using my calculator because we have our decimal values here. So we've 0.5 cubed minus 6 times 0.5 squared plus 11 times 0.5 minus 6. We have 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6. We have 1.5 cubed minus 6 times 1.5 squared plus 11 times 1.5 minus 6. 2 cubed minus 6 times 2 squared plus 11 times 2 minus 6. 2.5 cubed minus 6 times 2.5 squared plus 11 times 2.5 minus 6. 3 cubed minus 6 times 3 squared plus 11 times 3 minus 6, and then 3.5 cubed minus 6 times 3.5 squared plus 11 times 3.5 minus 6. Now, just to say about your calculators, be very, very careful to remember that you're cubing and you're squaring. Okay, so remembering your powers. And just to see the cubed button, so here is the x squared button, but beside that, depending on what calculator you have, but you can see there's an x and there's a blank box as a power. That's going to be your cubed button, but you have to put in the 3. So I'll show you now. We have 0.5, so 0.5, closing our bracket, to the power of 3. So you can see there I've opened up a box, but I have to put into the power of 3. Okay, I have to press my arrow to make sure I don't continue beside the power of 3. So press the arrow across to make sure you're just subtracting from that full term. So it's minus 6, and in brackets we've 0.5, and we're squaring that, plus 11 times 0.5, closing our brackets, and we're subtracting 6 at the end there. Okay, so we've minus 1.875. Okay, next we have subbing in 1, so we've 1 cubed, minus 6 times 1 squared, plus 11 times 1, closing our brackets, and we're subtracting 6, so that gives us 0. And then we've 1.5, so brackets 1.5 to be cubed, minus 6 in brackets 1.5, and that's to be squared. Okay, then we have plus 11 times 1.5, and we're subtracting 6 at the end here. So we've 3 over 8. I'm going to stick with decimals, so 0.375. Subbing in 2, so we've 2 to be cubed, minus 6 times 2 to be squared, plus 11 times 2, and then subtracting 6 at the end, so we've 0 again there. 2.5, so 2.5 to be cubed, minus 6 times 2.5, and that's to be squared, plus 11 times 2.5, minus 6 at the end, so it's minus 3 over 8, which is minus 0.375. Next we're subbing in 3, so we have brackets 3 to be cubed, minus 6 times 3 to be squared, plus 11 times 3, and then minus 6 at the end, we've 0 again. And then the last one is 3.5, so it's 3.5 to be cubed, minus 6 times 3.5, and that's to be squared, plus 11 times 3.5, and we're subtracting 6, and we end up with 1.875. Now you can see there's a bit of a pattern there with the output values, or the y values. So minus 1.875, 0.3750, minus 0.3750, and 1.875. Now those values not very nice, okay, because we're looking at the decimal numbers here. So you wouldn't be expected to be extremely accurate, but you just have to try your best when you're graphing it. So we'll have a look now. I'll keep those values in front of us. It's just making sure you can see both sets of values. So I leave them at the top there, and we'll graph it underneath. Okay. So looking now, we're going to draw our x and y axis with our rulers. We need to be very, very careful. I'm actually just going to fold that. Okay, so first of all, we're looking at our y values, and it goes up as far as 1.875. So I'm probably going to go up in 0.5s, and it goes down to minus 8.75, minus 1.875 as well. So we're going to make sure we have our x-axis and our y-axis, so that there is a y-axis above and below the x-axis. Okay, so 0.5, so we're going to again make sure we're going up in the same spaces. So we've 1, 2, 3, 4, 5, 6, 7, yeah. So I'm going to go 0.5 here, 1, 1.5, 2, 2.5, and 3, and 3.5. Okay, so 0.5, 1, 1.5, 2, 2.5, 3, and 3.5. And that caters for our x values here. So going up in our y-axis, we need to go up as far as 2, above and below 2. So I'm going to go up in 0.5s again. So we have 0.5, 1, 1.5, and 2. Okay, so 2, 1.5, 1, 0.5, and I'm going to do the same below the x-axis, so in our negative y values. So minus 0.5, minus 1, minus 1.5, and 2. So minus 0.5, minus 1, minus 1.5, and minus 2. Okay? So plotting these points, our first point would be 0.5 minus 1.875. So 0.5 is here, minus 1.875 is going to be here before minus 2. Okay, next point we're plotting is 1, 0. So we go to 1 on the x-axis and 0 on the y-axis, means it's actually on this point, on this axis here. Next one, we've 1.5, 0.375. So 1.5, 0.375 is before. Okay, so it's before our 0.5. So it's somewhere around here. We're trying to be as accurate as we can. Okay, so it's somewhere around here. Next value is 2 and 0. Okay, so 2 and 0 again is on the x-axis, 2 on the x-axis, 0 on the y-axis, so it's here. 2.5 and minus 0.375. So 2.5 is here, minus 0.375 would be just before our minus 0.5, so it's here. So 2.5 minus 0.375. Next one is 3, 0, which is here, 3 on the x-axis and 0 on the y-axis. And then the next one is 3.5, and it's 1.875. So 3.5 is here, and 1.875 is going to be just before 2, which will be around here. Now, they just look like random dots plotted, but we remember that our shape has to be, our shape is going to be kind of two curves. So I have to try and make two curves here. Remember our graph was plus 3x cubed at the start. Sorry, it wasn't 3x cubed, just plus x cubed in our table. So just x cubed. Now that tells us that our graph should be starting by going uphill from left to right and finishing with the second curve. So we're going to follow that graph in order of the points we plotted. Remember, we use a freehand sketch. We do not use a ruler to join the dots for a curved graph. Okay, we can see our graph, which was called g of x, so we label the graph, is going uphill from left to right at the start because it's positive x cubed. We have one curve, two curves, and the graph continues. So that's an example of our cubic function there. So remember, two curves this time. A little bit more work, and as you can see, the calculations themselves are a little bit more complicated. And again, you could see the use of the calculator because we were working with decimals here. Okay, so our next function, and our last function we're going to deal with in terms of graphing our functions, is an exponential function. Okay, now exponential comes from the word exponent, and an exponent also means a power. Okay, so what we're looking at here is the idea of our function having a power, and exponential growth means it's doubling or trebling. And if you think of COVID at the moment, they're talking about our second wave and the exponential growth we're seeing at the moment. This is because our table of values for COVID is looking like this, but it's looking like this. Okay, so it's getting very, very steep very, very quickly, and this is what an exponential graph would look like. Okay, so very, very important. So here, this is our base value. So our base would be a number here. Okay, and the x here is our variable. Now, for us to do this, we need to revise our laws of indices, which we have to do in our number section. So indices are also powers. So we've seen this previously in algebra as well. For these laws to work, you must have the same base. When we're multiplying two base numbers that are the same, we add the powers. So this becomes a, and we simply add p plus q. So a numerical example of this would be 3 squared multiplied by 3 to the power of 4. That would become 3 to the power of 2 plus 4, which is 3 to the power of 6. Okay, next one, same base, but we're dividing. So we keep the base, and this time we subtract our powers. So a numerical example would be 5 to the power of 7 divided by 5 to the power of 3. So it will become 5 to the power of 7 minus 3, which is 5 to the power of 4. Next one, brackets, remember, tells us to multiply. So we keep the base, and now we multiply p by q. So numerical example would be 4 to the power of 3 to the power of 2. So it would be 4 to the power of 3 times 2, which is 6. And lastly, we've seen this before again in algebra, anything to the power of 0 is 1. Okay, so a to the power of 0 is 1, 3 to the power of 0 is 1, 7 to the power of 0 is 1, a million to the power of 0 is still 1. Okay, and it's really important to know those 4 laws. Okay, you will use them in functions and calculus. You will use them in algebra. You will use them in number. So it's important that we make sure we know those quite well and how to use them in questions. Okay, so what we're going to do here is graph this function. And first of all, you can see the function is 10 to the power of x. The domain is -2 to +1. So this is our x values. So on our table, we have x goes from -2, -1, 0, and +1. Our graph is 10 to the power of x. Our function is 10 to the power of x. And we have our y values. So this is 10 to the power of -2. 10 to the power of -1, 10 to the power of 0, and 10 to the power of 1. Now if we go to our calculators and we do 10 to the power of, remember we have to create the box, it's to the power of -2. And that is 1 over 10. This is our change button, 1 over 100, or 0.01. Really tiny number. When the power is negative, it means it's a really tiny decimal number. 10 to the power of -1. So this is 1 over 10, or 0.1. 10 to the power of 0. Remember, anything to the power of 0 is 1. And then 10 to the power of 1 is obviously 10. So what we can see here is the numbers are really small and they get really, really big because remember I talked about that exponential growth. Okay, so our graph should look like this. Really, really small, gets really, really steep really quickly. So if we draw our function and graph our function, our x values are from -2 to +1. Okay. And our y values are all positive. So will I have space? I will just about have space. Okay. So I'm actually going to draw my y value first. So we 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 there. 8, 7, 6, 5, 4, 3, 2, 1. Okay, and I'm labeling that y and this x. And then we go from -2 to +1. So I'm just going to extend this a little bit. Okay, so -1, -2, and +1. So this is 1, -1, and -2. Now from here, our first point was -2 and 0.01. Okay, now 0.01 is tiny, 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 so you literally draw it just above the x-axis. Okay, next we've -1 and 0.1, and again tiny number but a lot bigger than 0.01, so just above again. You can see there's a small bit of growth here. 0, 1, so we go to 0 on the x-axis, which is where the x and y-axis cross each other, and 1 on the y-axis, which is here. Then we have 1 and 10, so we go to 1, we go all the way up to 10 on our y-axis, and what you should be able to see is the rapid jump here. So when I join the dots, okay, you can see there's a rapid jump here. Function was called f of x, and exponential growth means the growth becomes very big very quickly, which makes our graph very, very steep. Okay, now again, I know I keep saying it, but the link to COVID here couldn't be more accurate, because at the moment we're seeing a very, very big spike in our graphs if you were to watch the press conferences in the evening, because our cases are increasing much more every single day. So if you looked at maybe September, we were maybe here, and now all of a sudden in October we're getting a very steep increase because of, say, the 800 cases, 1000 cases. Okay, so that will be exponential growth. And if you watched those press conferences, you will hear them talking about exponential growth a lot. Okay, so it's very real life when you're talking about functions and graphs. Very, very much real life. Okay. Last part is composite functions. I've left this to the end because it's a little bit more complicated, and we don't talk about graphing composite functions. This is just very much working with numbers and algebra. So consider functions g and h are defined as g of x is equal to x squared and h of x is equal to 3x plus 5. Now, composite functions, we are going to be combining more than one function together. Okay, it definitely comes up in the Leaving Cert, but not sure if it's in the army course, to be honest. I don't remember seeing it before, but I'll cover it anyway. So when we combine these functions together, they're asking us here to evaluate or get an answer for h of g of 3. And then evaluate or find a value of g of h of 3. Now, what we can do here first of all is find g of 3. If g of x is equal to x squared, then g of 3 would be 3 squared, which is 3 times 3, which gives us the number 9. Okay, so we've this part done first of all, and now they want us to find h of 9. Now what we do here is we apply what's happening to the x in the h of x function, and we're applying it to 9. So the x part of the h of x function is being multiplied by 3, and then 5 is being added to it. So what we're going to do with this 9 now is apply what's happening in the h function. So it becomes 3 times 9 plus 5. So 3 9s is 27, and 27 plus 5 is 32. So the value of h of g of 3 is 32. Okay, so a little bit complicated. I'm going to do another example to make sure you understand the idea here. So this time it's the reverse. This time they're looking for g of h of 3. Now I know I can actually find a value for h of 3 because h of x was 3x plus 5. So h of 3 is going to be 3 times 3 plus 5. 3 times 3 is 9, plus 5 is 14. So now what we've to find is g of 14. So g of 14 is applying what's happening to the x in the g function to 14. And in the g function, x is being squared. So now we have to find 14 squared. 14 squared is 14 multiplied by 14, which is 196. So g of h of 3 is 196. Okay, so this is combining more than one function. Now I don't think it comes up in the army course, but it definitely comes up in the Leaving Cert. And I suppose what's important here is you're combining more than one function together. So it could be 2 or 3 or 4 functions. And generally in ordinary level maths, you only see really the combination of maybe 2, maximum 3 functions. Okay, going to do another example of this because the notation is a little bit different. Okay, so the notation is different here. It's f and there's a small circle g of 2. So that's the same as writing f of g of 2. And here it's the same, g little circle f of 2. So it's g of f of 2. So f function here is f function here is f of x equals 6x plus 2. G function here is g of x equals x cubed. So what we have is, first of all, f of g of 2. Now I know I can find g of 2 because g of x is equal to x cubed. So g of 2 is going to be equal to 2 cubed. Now 2 cubed is 2 by 2 by 2. 2 by 2 is 4, 2 by 4 is 8. So g of 2 is 8. So if I have g of 2 equals 8, now I'm trying to find f of 8. So remember, I apply to 8 whatever is happening to the x in the f of x function. So this becomes 6 times 8 plus 2. 6 eighths is 48 plus 2, which is 50. And that means that f of g of 2 is equal to 50. So that's part 1. Part 2, we're doing the reverse. So we've g of f of 2. Now we know f of x was 6x plus 2. So f of 2 would be 6 times 2 plus 2. 6 2s is 12. 12 plus 2 is 14. So we're now finding g of 14. So we're applying what's happening to x in the g function, and it's being cubed. So now we need to find 14 cubed. which is 14 by 14 by 14 on my calculator, is 14 to the power of 3, which is 2,744. So G of f of 2 is 2744. Now they'll often ask, is f of g of 2 equal to g of f of 2? And more times than not, they are not equal to each other. Okay, so that's probably the most challenging part of functions and composite functions. That's why I left it till the end. As I said, definitely comes up in the Leave Insert, but not sure if it comes up in the Army course at all. Okay, so I'm going to leave you with some questions to try. These are questions based on both videos for functions. Okay, so 2 videos, and I'll send you a picture of those once we are finished with the videos.